hopefully I'm not cutting into your conversation. This is Mike against XCDX. I've got a group of prospective and we've been talking about repeat. This is kind of a unique one and neat one. I was hoping that I could get some reports of people who are listening, giving us a geographic location, and particularly those who might be out of state or out of country.
Comment. I read you loud and clear in 6IQO. I'm a fairly new ham. I am in Lake Havasu, Arizona.
At W7B&W, Baldwin, Arizona. Three Delta November up in Alaska. What's up?
KV6 Echo Victor Radio, Los Feliz, Texas. AN6 SEO Oak Run, Northern California.
Duck Valley, California.
KI5 GKF, Hockley, Texas. Well, you might have heard there. Arkansas. Wind system. That's what we're listening to. Talking across the U.S. with a handy talkie. Yeah, take a little quick little demo there. Yeah, we don't hear the comment. I just put that on mute over there. Yeah, so Allstar, what you were listening to was the wind system. Wind system is a gathering of repeaters, simplex nodes, hubs, and various other connections. We heard in Alaska, Arkansas, Texas, California, probably a few other ones in there that I missed too, but who is counting? Anyways, so what is this video about? This video is about my Allstar simplex node, specifically more about Allstar for those who want to know what it's all about. So just a real quick synopsis, what you were listening to there in the beginning of the video was this box. This box was transmitting that signal on 439.975 on 30 milliwatts into my handy talkie, which is also on the same frequency. So threw my call out there. I'm pretty sure they heard me. And it's an easy way for someone with a technician or someone with non-capable of getting HF to reach out to the world very easily. Yes, you are bound by the internet, and if you don't have the internet, you can't do Allstar. So that's the one system that it's relying on. Now with Allstar, there's 3 components primarily. So I'll just go over this real quickly on these 3 components. This is not meant to be a build guide nor a how-to, just really more of a little bit deeper dive than you may have heard about Allstar. You may have even heard it on a repeater, or was kind of wondering, maybe I had a quick little QSO about it, but never really quite understood what it was all about and how do you go about getting into it. And that's what this video is about. So what is it and how do you get into it? There's multiple different ways. You can do a homebrew, you can buy something, you could simply look up repeaters. There's a lot of different ways to get into the network. So first off, what is Allstar? So if you go to allstarlink.org, that is the network. These are the great people, great amateur radio operators who maintain this system, and they create it for us, and we use it. So this is what you're looking at here. There's a lot of information here. I'm not going to go great in depth detail, but essentially, it's a linking. It's a linking service that links multiple repeaters and users. As of today, which today is September 10th, 2020, there are 19,970 users and 16,491 nodes. Now a node is, this is a node. That is an example of a node. A repeater that's connected to an Allstar network is a node. But that's pretty, so a node is a way for it to connect into the system. Users are hams. 19, almost 20,000 hams are in the system. So that's a good sign there. Pretty large system, not gigantic, but very large. All analog. Everything there is analog as far as voice goes. You're sending in analog and you're getting analog. None of this digital stuff. So it's like you're talking to a repeater. I have this node set up. It almost sounds like a repeater. It's got the same tones and everything. You know, it's got the little beep after I transmit to it, and the reset tone and all that fun stuff. It's got my, it sends out my call every 10 minutes, just like a repeater should. But that's what Allstar is. So go ahead and go read up on it. There's a lot of information in here. You can read the about. And if you want to sign up, you just click the little button, log in, sign up for your node, because that's the first step. You have to request a node in order to build a node. So request the node, you get your password, so on and so forth. There's a lot of directions in this website on how to do that. So that was one piece. That's the network, Allstar network. There's two more pieces, hardware and software. So let's go take a look at software real quick. So software, I got another website for you. This one, scroll up the top, hamvoip.org, HamVoip, Allstar Asterisk on the Raspberry Pi 2, 3, and 4. Most people use 3. This is essentially the operating system that runs on the Raspberry Pi. So to run Allstar, you need a piece of software, and this is an operating system, runs on a single board computer, which is the Raspberry Pi. It runs all the computations that it needs to run over on that little small computer. This is Raspberry Pi, in case you're wondering. That's a little Raspberry Pi, a little cheap little computer that run about 30 to 60 bucks, depending on which one you get, feature set, things like that. Lots more information in here on how to download, install, and configure Allstar Asterisk, which is the software, and also some notes where you can, if you don't want to build a node, man, you can buy one ready-made, just plug and play. It's spend a little more money, of course, but that is available out there. Also, some other ways that other people have built nodes. Let's count how many different ways you can build an Allstar node. Multiple different ways you can do it. A lot of repeaters use the Allstar Asterisk software as a repeater controller because it has all the functionalities and runs on a tiny little computer that barely consumes any power, and you can connect to different networks with it. So that's the big benefit. So that's software. Let's go take a look at hardware. So hardware, this is hardware, what you're looking at here. This is one example of one piece of hardware, and this is the directions on how to put said hardware together. As I mentioned before, there are multiple different ways to put nodes together. You may have seen it. The yellow box, Techno by George, G7RPG, he puts together one. Clear node. There's multiple different ways to put these nodes together. This is one. The reason I chose this one for my node, because it was the easiest to understand for me. Just the way this particular ham put it together for me, it made sense. The step-by-step, the way he worded things, the way he explained things just made sense. 5-step process he has in here, going from intro to making modifications to the radio, which is this guy, little Baofeng 888. Sound fob, or what we'll call the CM119, sound card or sound fob. Some circuitry to tie everything together in step 4. And step 5 is putting everything in a box. You notice it doesn't cover the setting up of the software. This is just hardware. Software is on this side. Just want to make that clear. So recap real quick on these 3 websites. allstarlink.org, that's the network. You have to start there by requesting a node number and creating a password and get approved. You're going to have to put in, you got to be an amateur radio operator. You got to have a valid call in order to get in the system. So there's that piece. You can read up on it in there. Software is hamvoip.org. All the directions are located within this website. And then take your pick your poison for hardware. You can use this one, squirrelengineering.com. There's some other ones out there, and you can just do a search for Allstar link node build or something like that within Google, and something will come up. But specifically, let's go over this one in case you want to try to reproduce whatever I did to get better understanding. So at this point, from this on part in the video, I'm just going to cover on this node that I built using the and everything that I learned from it, some of the lessons learned, mistakes that I've made, and what I do it differently. So first off, I'm going to go. There's three main components to this node. You have a power supply, you have computer, and you have transmitter. Three components. So that's the way I'm going to cover it. First, the transceiver. Right here. Baofeng 888S. Pick them up from Amazon. 2 for $20. Pretty cheap. They are not very good for voice work, for just using as a regular handy talkie, just talking into it like you normally would. The battery is really small. It's pretty fragile. It's pretty flimsy. I would never use it as a handy talkie. But they make great node radios, and I'll tell you why. They make great node radios because they're easy to modify. They're easy to change. They're easy to find things, and they're not that complicated. They're pretty simple. Yeah, that's why they use them. And they're cheap. Big plus, big plus, big cheap. So let me zoom in here. You can look at the node, the radio I have in there. You notice it looks a lot different. The top looks the same. I got the same antenna and the same knobs. One thing you're going to do before you do anything to this radio, you got to program it. I use the the typical Baofeng programming cable and chirp. Pick my frequencies. Program tone squelch, not tone, but tone squelch. When I used this particular one, it set a frequency 439.975 with a tone squelch of 77. But you can really pick whatever you want. Then on the HT, I do same frequencies, but tone 77, not tone squelch on the HT. Tone squelch, tone. So there's that. And other things I got in here is you got to attach some wires to this guy. So after you program it, then you got to attach some wires. So there's 6 wires I had attached to this. For one thing, I wanted to eliminate the battery. I wanted to eliminate this battery because it's small. This thing's only 1500 milliamps. It's not going to last very long because you think about a node, it's transmitting all the time. So, you're never using a handy talkie and you transmit for a long time, the battery doesn't last as long. Same thing with these. So what you do is you eliminate the battery, feed power and ground directly into the radio itself. They need about roughly about 4 volts to run this, a little bit less than 4 volts. And you can do that just using some buck converter and a diode, which we'll get in here. So that's 2 wires. There's 4 more wires that need to be connected in here, and you can kind of see them in there. They're kind of wires all strewn about in there. So we got ground, we got power. We need audio, both on transmit and receive. We need transmit audio and transmit receive and receive audio. So we got those 2. We need some signaling. So Allstar, so the software knows what's happening when the PTT, when this thing needs to be keyed up, and when this thing is receiving a signal, COS, carrier operated signal. So recap: 6 wires, power, ground, transmit, receive, transmit audio and transmit and receive audio, PTT and COS. Those are the 4 wires you need to tap into here. And that's it with a transmitter. There are some few little modifications. You got to remove the microphone on the board itself. Don't need it. Get rid of the speaker. Get rid of the little unsoldered light on there. Highly suggest that you make the low power modification to these things. They're rated at 1 watt transmit. That's considered high power for these little things. But with any handy talkie, longer you transmit, these things get pretty toasty. So there's a few little modifications you can make. There's some articles out there, especially on HamVoIP. There's some articles in there on how to make the low power modifications for the Baofeng 888. Drop it down to between 30 and 60 milliwatts. So you can pick your poison on how far you want to take it down. On my particular node, I got it down to about 40 milliwatts. So a little less than half. Haven't had any problems. So there's that. That's the transceiver. Between the and then next would be power supply. So how am I going to feed this power? Now I could use a traditional power supply from like MSJ or any kind of switching power supply. Yeah, I could do that. But if I chose to use an old computer power supply, which you see right down here in the bottom left-hand corner, and so pretty much what I did is look at the wiring diagram, made it to where I grounded a wire and powered up the thing with a switch, with a toggle switch. So I just flip a toggle switch and it powers, and it gives me 12 volts on the yellow on the yellow lines. And that's all I'm feeding, that's all I'm getting from this. So 12 volts, and then it goes to a bus bar, and then the bus bar, power and ground over to my buck converters. The reason I'm using buck converters in here is because I want stable power. So if I feed 12 volts in, and I only ever need about 5 volts roughly. I'm always feeding 12 volts in. I got lots of headroom. No problems with power there. And that's what the two little boards here, those are both buck converters, and they take 12 volts and drop it down to whatever voltage I need. The one here on the right is feeding the computer, which is down here, we'll talk about in a minute, and it's also feeding the radio, the transceiver, the Baofeng. Let's have that set for 5 volts because that's what the Pi needs. And then remember I said earlier the Baofeng needs a little bit less than 4, so I have a diode in line with the power jack on the Baofeng to drop it down from 5 volts using a diode. So that's that one. This other one over here, that one's simply just controlling a fan. That's a very cheap way to make a fan controller. You just turn down the voltage, pretty much. It's a standard 3-pin computer fan. Came with that computer. Just pretty much just wired it up and use the voltage setting on the buck converter to adjust the fan. It cools, keeps the computer cool because these things do run a little toasty from time to time. So that's power. That's how I have power run. Let's get down to the computer parts. So you see down here, this is where most of the magic happens on the Raspberry Pi. This is Raspberry Pi 3B+. I'm not using a Raspberry Pi 4. I personally think Raspberry Pi 4 is a little bit overkill for simplex nodes because it doesn't need that much processing power to run these nodes. Plus, the faster, more RAM, more processing power you have, the hotter they get. It's just the nature of the beast. So if you have a little bit lower spec board, it doesn't run as hot. Right now with that thing running on a muffin fan, I can look at temperature. This is the interface, by the way, of my node. I can see what it's doing. It's running at 100 degrees, or 38 degrees C, so she's running nice and cool. Yeah, you can kind of see it's just telling me what I'm connected to and things like that. That's the software side. Okay, so you'll see over here, this is the power line that's feeding this little computer. And if you see the little black deal right down there, that's the micro SD card. So that is a 16 gigabyte card that I put in there. That's all it needs. It doesn't need a big, huge card. You can actually run it on about an 8 gigabyte card if you really have to. Some other connections here, you'll see this little line that kind of strings about and a little solder joint on top of that USB port. That's the ground. You'll notice here, I only have the power going to the radio. Ground actually comes through all this stuff. And so avoid ground loops, so I don't get any funky noises. That was one change that I changed from what Squirrel Engineering had. I'm getting the ground from the Pi, so I'm always getting the ground from one location, and that's the Pi. So that's that. You'll see over here this thing with a little zip tie on it. That is the CM119 sound card. That's where I tap my transmit audio and my receive audio and PTT and COS into the Raspberry Pi or the Allstar Asterisk software. That's where it gets all its connections from, right there via USB. It's probably the hardest part about this whole node build is this little sound card attaching the wires to the various places you need to. Two of them are fairly easy. The transmit audio and the transmit and the receive audio. Those ones are fairly easy. It's the COS and the PTT, because you essentially need to attach very, very thin wires to a chip. You need to crack open that sound card, attach wires to the chip. specific pins on that chip, and you can't bridge any pins or anything like that because it won't work. I can tell you that flux, good soldering iron, and a magnifying glass, or even better, a microscope, work wonders. You can get in there. Don't put too much heat in there. You put too much heat, you cook the chip. But hey, if you mess up one, not that big of a deal. They're pretty cheap. You get them on Amazon. The blue line you see here, that is the internet. That's what connects this whole node to the Allstar network and allows me to connect everything. Hardline is always better than Wi-Fi if you can get it, because it's one less RF that you're sending out. All right, so let's talk about some other things. You'll notice I didn't talk about this little breadboard that's up here. That's really just there's some transistors, diodes, and not transformer. How am I all of a sudden I got a brain fart? I'm sorry. Transistor, that's the word I'm looking for. A transistor in there, a diode, and a few resistors in there. Resistors to level the audio, diodes to prevent flyback voltage, and the transistors there for the PTT circuit. So that's kind of how that makes everything, ties everything together, in other words, and just use the board to do that. I did use some old USB cables, mainly because hey, it's good quality wiring, and it comes with shield. Those are typically shielded, so I use that for most of the audio and PTT and COS lines. I put ferrite beads wherever I could to eliminate any noise through the various components. You can see there's 3 ferrites, one here on the power feeding the radio. There's one here on the power feeding the Pi, and then there's another one right over here on the line going from the little circuit board to the transceiver. And then additionally, to block out RFI, I put everything inside this old computer case. Had it laying around, had a cooked motherboard. It was no longer a useful computer anymore. So, but the case was still good, so I managed to just do a little bit of fabrication and make everything fit in there, nice and neat. Some extra room in there for some stuff too. Could do that. So that's the little node I built. That's just one example. This one just stays, in my shack all the time, and I can connect to it. I can walk to the mailbox and walk down the street. I would say, based on the 40 milliwatts that I have, or its current location, a couple football fields, and I can hear and key up this node with HT. Sometimes I have to turn it on the high power, but most of the time I'm running on low power if I'm just sitting at my desk or on the couch or whatever. And if you're wondering how do I control the node, I can either control it through this interface by logging in. I can log in and I control it through here, through the computer, or I can just do it through the DTMF tones on the face of the HT. There's a number of codes that you do to connect, disconnect, dial up other nodes, do all kinds of commands. You can do all kinds of things, just like a normal repeater controller. So that's all in there. So that was it. Here's another example of a portable Allstar node. This one I bought from G7 RPG. This node number is 50559 in case you're interested. But you see there, everything fits inside a black box. Of course, I couldn't leave anything alone, and I threw a digital hotspot in there. But there's an Allstar node shoved inside that little black box. That's in there too. So that's an example of a ready-made one. There's a link in here. This is what you're looking at here is my QRZ page. So, and you'll notice here that I got the node listed. So if you ever want to know, if you want to get a hold of me, you can get my email through my QRZ page. And you can also see what other kind of information I have. Like this video is posted there. May have some other information there that you can see what I'm up to. So hope this video was helpful to help you understand what Allstar was about and kind of give you some ideas, maybe spark an interest in you for you to go out and build an Allstar node. By the way, total cost, I mean, for that particular node, $150 maybe, somewhere around there. I never really added it up. It was more fun. It wasn't adding up. But if you're creative, you can get them pretty inexpensive. It's just going to take a little more brain power and thinking and doing. You know, just like with any homebrew project, you're gonna take a little bit of trial and error. But that's all I had for you. Hope this was helpful. And 7-3 to you and yours. And I hope to catch you and see you on Allstar. Have a wonderful day.